Morning folks, today's lesson is on pressure. Pressure is related to force and area. So let's crack on and get the job done. Pressure is a measure of force exerted on a surface. If you push down onto a table, you are exerting a force onto the surface. You are applying pressure. And pressure is measured by force divided by area. It's how much force is being applied per unit of area. Here's our first example. Find the pressure exerted by a force of 200 newtons on an area of 50 squared centimeters. That N, by the way, if you didn't know, N is for newtons. It's a unit of force. So pressure is force divided by area. So that's 200 newtons divided by 50 squared centimeters. And that's 4 newtons per squared centimeter. Note the units. Our force was given in newtons. Our area was given in squared centimeters. So our measure for pressure is newtons per squared centimeter. In example 2, we're trying to find the pressure, but we're only given the dimensions of the brick. Therefore, we need to work out the area of the brick that is in contact with the table. And that area of the brick in contact with the table is 20 centimeters, which is the width of the brick, multiplied by 7.5 centimeters, because it's the base of the brick that is in contact with the table. So 20 centimeters times 7.5 centimeters gives us an area of 150 squared centimeters. Pressure is force divided by area. Now the force is the weight of the brick, and we look at the question, we're told the weight of the brick is 15 newtons, so that will be our force. Our pressure therefore is 15 newtons divided by 150 squared centimeters, and that's 0.1 newtons per squared centimeters. Note the units. Our force was in newtons, our area is squared centimeters. So our unit for pressure is newtons per squared centimeter. And in example 3, we have exactly the same brick, this time turned on its end. And the difference that makes is the contact area of the brick, 5 centimeters, multiplied by 7.5 centimeters, that's the base area, that will be much smaller, and consequently the pressure exerted on the table, as we shall see, is going to be greater. So the contact area is 5 times 7.5, that's 37.5 squared centimeters. Force divided by area, it's the same force, 15 newtons, divided by a smaller area, and this time it's 0.4 newtons per squared centimeter, which is greater than 0.1 in the previous example. We can make things a little bit quicker with a force, pressure, area triangle. In this example, we are trying to find the pressure exerted by a 20 Newton force over an area of 5 square meters. Because we're trying to find the pressure, we place our finger over the P for pressure. And we're left with F over A, which is force divided by area. We can then insert our units of force and area, 20 divided by 5, and that's 4 newtons per square meter. Note the units, force given to us in newtons, area given to us in square meters, so it's Newton per square meter. In this example, we are trying to find the force. So if we place our finger over the F for force, we're left with P and A next to each other. And in algebra, 2 letters next to each other would mean multiplied by. So force is pressure times area. We substitute our units, 40 newtons per square centimetre being multiplied by 2 square centimetres, but we need to check. We need to check that the units of pressure and area are consistent, and we can see that the units of pressure are given in terms of newtons per square centimetre, and our area is in square centimetres. So the units are consistent, which means we can simply multiply the numbers together. And our final answer is 80 newtons. Newtons because that's the unit of force given to us in the pressure units. And our final example, we're trying to find the area this time. So you'll not be surprised to know that we put our finger over A for area. And what are we left with? We're left with F divided by P. So area is force divided by pressure. Our force is 40 newtons. Our pressure is 100 newtons per squared centimetre. The units are consistent with each other, both newtons, and therefore our answer is 0.4, and the units for our answer are squared centimetres because our pressure units were given in newtons per squared centimetre. Let's put all this together then in a recap. Pressure is the force per unit of area, and it's measured by force divided by area. When calculating pressure, make sure your units are consistent with each other. And to help make things a little easier, you can use the force, pressure, area triangle. And if you've understood all that, that's great stuff, because it means you've got the job done.